Hello and welcome. In this video I'm going to do a quick example of how to use NX Advanced Simulation to analyze a simple beam using shell elements. And what you see here is just a simple surface that's 2 inches wide by 10 inches long. That's going to represent our beam. And to do that, what we want to do is start the Advanced Simulation application. And what you can see here is that the Simulation Navigator has been activated. And on the part here, we can right click and do New FEM and Simulation. And in the New FEM and Simulation dialog box, you see that we're going to create two new files, a FEM file and a SIM file. We're going to associate to the master part. And for bodies to use, we're going to go down to the Select and click on this sheet here and go ahead and click OK. And this will bring up the solution dialog box. And what we want to do here is give this a name. We're going to call this shell beam analysis and click OK. And you can see now in the simulation navigator that it's created the simulation file, the FEM file, and also this shell beam analysis solution. So now what we need to do is mesh, create our mesh with shell elements, and we do that in the FEM file. So double left click on the FEM file, and what we can do is the first thing we want to do is assign a material. So we're going to hit the Assign Materials button from the Advanced Simulation toolbar, and we'll select our body, our sheet body there, and just give it a steel material. And the next thing we're going to want to do is just go ahead and jump right in and mesh it. So we're going to, from the Advanced Simulation toolbar, we're going to select the 2D Mesh option, and we're going to select our body, and we'll enter a value of 1, and go ahead and click OK. And the application will generate the mesh. And the only thing we need to do now for the mesh is we need to define a thickness for these shell elements. So what you can do is expand the 2D collectors, and on the thin shell, go ahead and right click and select Edit. And what we want is this shell property here. We're going to edit that and enter a value of 1/2 inch. Go ahead and hit OK. And what we can do is we can edit the display of this shell collector and turn on element thickness. And now you can see our elements have a thickness associated. Well, now that we've got our mesh, we can switch back over to the simulation file to define our boundary conditions. This is going to be a simply supported beam, so we're going to do a new user-defined constraint. And on this back edge, we're going to fix this in the Z direction. So we're going to go ahead and do a fixed constraint on the Z, DOF3. We're going to hit apply. And then on this opposite edge, we're going to take advantage of some symmetry. So that is going to be a symmetry plane, and to constrain that, we're going to say, okay, we can't translate across the plane of symmetry, and we can't rotate about the Y. I'm going to hit OK to that, and then just to stabilize the model, we got to do one more constraint. We're going to pick the end of that curve there, and we're just going to fix it in the Y degree of freedom so this can't slide back and forth. Alright, now that we've applied our constraints, we can go ahead and create a pressure load on the surface. And we're going to enter a value of 10. And you can see that pressure is going in the positive Z direction. I want to go ahead and you can see that pressure has been applied. Now that we've got our constraints and our loads, we can go ahead and solve the model. So we're going to hit the Solve button, click OK, and you'll see a bunch of dialog boxes open. There's a solution monitor and a job analysis monitor, and I like to keep my eye on the job analysis monitor. When it's done running, it'll show completed there, and you can just hit cancel. You can close this window, close that window, and you'll notice that there are results available now. So let's go ahead and double click those results to start the post-processing navigator. And let's go ahead and take a look at the element nodal von Mises stress. So with that pressure load applied, we have a stress shown there, and if we look at the model, it looks about right. We're curving up a little bit, and we got a value that is very similar to the solid model introduction that's also posted on the channel. Well, that concludes this quick introduction to shell elements with a simple beam model. Thank you for watching, and if you have any other questions or want to know some more information about NX Advanced Simulation, go ahead and visit us at the web at www.predictiveengineering.com. Thanks for watching.